absent students want to watch it. All right, so this is the, I'm going over questions from the Module 2, Part 2 review that students have. I'm not going over all problems, only the ones that students ask questions on during our review today. So I'm starting with number 2, which is a division problem. And I taught you that when you are dividing two rational expressions, you have to keep the first fraction the way it is. You change multiplication, or I'm sorry, you change the division symbol to multiplication, and you write the reciprocal of the second fraction. But remember, when you're doing excluded values, that 5 minus r was at one point in the denominator, so it's going to give me an excluded value. Let's go ahead and write that. What would r have to be to give me a 0, 5? So it's going to be in the numerator now, but it was once in the denominator, so that's going to be part of our excluded values. Okay, before we multiply, let us factor wherever we can. Okay, and I'm not going to do the t-chart and divide and slide for everything because a lot of them we can do in our head, especially when a is 1, right? So r squared plus 5r plus 4. Two numbers that multiply to get 4, add to get 5. 4 and 1, a is 1, so we just know that that factors to r plus 4 and r plus 1. And I'm multiplying that by 5 minus r. And you know what I'm going to do there? I'm going to rewrite that as negative r plus 5. And then in my next step, I'm going to factor out that negative sign because I bet we can cancel something. And I should have done it then, but I started writing my parentheses before I thought about it. Okay, denominator. Two numbers that multiply together to give me negative 5, add to get negative 4. Negative 5 and positive 1. Negative 5 times positive 1 is negative 5, and negative 5 plus 1 is negative 4, so that works. And then that denominator is 1. Do I need to write a 1? No. So, see right now how we have it written, that r minus 5 wouldn't cancel because it's negative r plus 5, right? However, if we factor out that negative, I'm going to put it first. So I'm going to factor out a negative 1. You can just put a negative sign. So that would make it r minus 5. So the numerator is completely factored. So now see how when I rewrote that in standard form and then factored out the negative 1, you can see how it will cancel. If we would not have done that, we would not have canceled it, then that would make our problem wrong. And then r plus 1 cancels as well. Where did I factor what? I just did it in my head. Yeah, because we know, I mean, we can do, if it's not a dividing slide, that's super easy to do in my head. So I didn't show my work. Do you need to see it? Oh.
For mine, when I did it, I got like 5 minus r and then r minus 5. And I didn't think it was canceled, so I got the wrong answer.
5 minus r? Oh, you mean for the negative r plus 5?
Yeah.
Right. So if you leave it that way, you're going to be like, oh, can't cancel that. So I would always write it in standard form. So I wrote it in standard form, and then I factored out that negative. And when I factored out that negative, then the r minus 5 was able to cancel. Okay. So we have left in the numerator negative 1 times r plus 4. So we don't need to write negative 1. But I can't just write negative r plus 4 because I'm not just subtracting the r. So you have to put parentheses, or you have to distribute the negative. Either case. So on the answer sheet, they distributed the negative. And we can see that r cannot equal 5 from the original and also from the r minus 5. And then also r cannot equal negative 1. Coolio? And I'm going to probably have to speed it up because I'm sure we have a lot of questions and I want to get to as many as we can. So that's, I'm guessing that negative, the 5 minus r is what messed y'all up on that problem. Okay. Number 6. And probably the same thing on this one because it has a 7 minus m. You would want to rewrite that to negative m plus 7 and then factor out the negative. I'm guessing that's what we had the confusion on. So I'm going to change this to a multiplication problem. Oh, and because 7 minus m was once in the denominator, What can 7 not equal because of that denominator? 7, because 7 minus 7 is 0, right? So we'll go ahead and say that. I can factor 4m minus 28. So 10 over 4 times, that would be m minus 7, right? Times, I'm going to convert that. That would be negative m plus 7. If I write it in standard form, the negative goes with the m. Factor out the negative, and I have negative 1 times m minus 7. So when I multiply my numerators, I have 10. I'm going to go ahead and distribute this negative because I'm going to combine like terms. Minus m plus 7 all over. And the denominator, I'm not going to distribute that yet because once I get, oops, y'all can't see. Once I get that numerator simplified, I might be able to cancel something out. I might not. We'll see. So in the numerator, we have, I'm going to put the negative in first. And what's 10 plus 7? 17. What is happening? I'm not getting the same thing. I'm obviously doing something wrong. No, you cannot do that. Well, I could, yeah. Because it was all multiplying. Okay, let me go back up here. In my numerator, 10 is a factor, and negative 1's a factor, and m minus 7's a factor. So instead of me multiplying it all together, since they're all factors, if that was just, if I wasn't distributing that negative, if that wasn't all factors, then I could not cancel the m minus 7. Okay, so because 10's a factor, negative 1's a factor, m minus 7's a factor. So yeah, I could cancel those m minus 7's out. Right, so 10 times negative 1 is negative 10 divided by 4, and that reduces to negative 5 halves. M cannot equal 7. Anything else? So we're good. Cool beans? All right, let's do number 9. Another division problem, so I'm going to change it to multiplication. Could I cancel these 3x squareds in the first fraction right away if I wanted to? No, because isn't 3x squared minus 6x,
Oh, yeah.
that's a binomial, right? All or nothing. 3x squared is a monomial, we can't do that. Okay, so my numerator, those are monomials. So I'm just going to multiply those together. We don't factor the monomials. That should be 9x cubed, right? Over, now the denominator, 3x squared minus 6x, that has a GCF of what?
Yeah.
3x. Factor it out, what am I left with? X minus 2. And then that is being multiplied by x minus 7. So the denominator is completely factored. My numerator is just a monomial. So if I have any monomials in the denominator, if anything will reduce, I will reduce it. Can I reduce anything? Yeah. The 3 and the 9, right? And the x cubed and the x. So 3 divides into 9 3 times. So I'll change that to a 3. 3 divides into 3 once. And then the denominator, x cubed divided by x, that x in the denominator will go away. And I'll be left with x squared in the numerator, correct? Okay. So that gives me 3x squared divided by, now I just have 1 times, I don't need to put that. So x minus 2 times x minus 7. And the answer key did not distribute in the denominator, so I'm not going to. We have to also list our excluded values. X cannot equal. From the 3x that got moved to the denominator, what can x not equal there? 0. And then let's look at the denominator once it was all factored. It's easy. So 3 times x can't be 0. We already have that one. For x minus 2, x cannot equal 2. And for x minus 7, x cannot equal 7. Cool beans. Hopefully I got the same answer. Yes, I did. All right, number 10. Make sure you don't get your B's confused with 6's. And that's multiplication. So do I do the whole keep change flip thing on multiplication? No. Okay. 40b plus 16. I have a greatest common factor of what? 8. 4 is a common factor, but your greatest is 8, right? So if I only factored out a 4, I would still have a common factor in my parentheses. So if I divide out at 8, I'm left with 5b plus 2 times 2b squared. When I multiply fractions, multiply numerator times numerator. Bottom left, I can factor out what? 2b squared, because they both have 2b's. The first term has 3b's. They both have at least 2b's, so I can take out b squared. When I factor that out, I'm left with 5b plus 2, right, times b minus 8. So the 5b plus 2 cancels. 8 is a monomial. 2b squared is a monomial. I can reduce that. 2 divides into 2 once. 2 divides into 4, or 8 4 times. So let's see what that gives me. So now I can do 4 times 2b squared is 8b squared divided by, let's see, I still have a monomial of b squared times b minus 8. And I could have reduced that in my last step. I kind of forgot about that 2b squared, so I can reduce it now, right? The b squareds will cancel each other out. So I have left 8 divided by b minus 8. Can I cancel those 8s? No, 8's a monomial. B minus 8 is a binomial. All or nothing with a binomial. So b cannot equal from my, oh, that was multiplication. This is not division. So b cannot equal from 2b squared. Can't be 0. What about from 5b plus 2? If I set that equal to 0 and solve for b, what is it? 2/5, but it will be negative because we'll subtract the 2, right? So negative 2/5, and b cannot equal 8. Coolio? Oh, I have questions. I don't know which one y'all are talking about. Let me see. Scroll up. So Jomar, if you distribute that, it's totally correct. But on the test, they may distribute, they may not. They're not going to include both, one distributed and one factored. So just look in your multiple choice and see which way it's given to you. So what I use to make your review, that program, is the same thing I use to make the test. So the answers that you saw, that's the way that the test, the generator, that's the way that they put the answers. So it's not what I prefer. It's just however they leave it. So just look at your multiple choice and pick whichever form they leave it in. Now, if it was questions that weren't multiple choice, which I already told you I was giving you multiple choice, then it would be fine either way, okay? And remember, I don't know if I told you all this or not, but if you bomb the test, I will let you do a test retake. Did I tell you this?
Yeah.
Since we're not having test recovery or grade recovery, quarter recovery anymore, credit recovery, grade recovery, whatever they call it. So I will let you retake the test. But the new test will obviously be different questions, and it will not be multiple choice. So it will be best if you're prepared on the day of the test so that you get multiple choice. Retakes will be not multiple choice, and if you are absent on test day and it's an unexcused absence, your test will not be multiple choice. A lot of kids tend to miss on test day. It's weird how that happens. I don't know why. It just seems like it makes it harder when they take it, 2 weeks down the road, already forgot something, moved on to something else. So If you're absent, if it's an excused absence, cool, no problem. You will have a multiple choice test. But if it's unexcused, or there's not a good reason why you were absent that day, then it will not be multiple choice. Okay? Most of y'all are always here, so it's not a big deal. But all right, anyway. Okay, so next section is adding and subtracting. So on this section, I will take questions on 11 through 30. Dang, I gave y'all a lot of those. Let's just look at the first page first. 11 through 18. 14. Okay. 14 and 16. All right. Okay, that's enough. Want to make sure I get to the last section as well. So let's start with 14. And again, I like to write mine vertically. Okay, before I determine a least common denominator, I bet I can factor the denominator of that bottom fraction. So let's put that in factored form first, and then we'll find a least common denominator. I'll do that down here. So for 3v cubed minus 27v squared plus 60v, what's the greatest common factor? 3v. So if I factor that out, I get v squared minus 9v plus 20. So I need two numbers that multiply together to give me positive 20 and add to give me negative 9. Negative 5 times negative 4? Negative 5 times negative 4 is positive 20, and negative 5 plus negative 4 is negative 9. That works. A is 1, so we don't need to divide and slide, right? Perfect. Okay, so look at your monomials separate than your binomials. So my monomials are 3v and 2. What's the smallest number? Sorry, I'm all over the page here. What's the smallest number that 3v and 2 will both divide into evenly? 6v. And then I'm also going to need a v minus 5 and a v minus 4, right? Are y'all cool with that? Okay, so let's look at that top fraction. Oh goodness, this is going to be quite the doozy. 2, first of all, let's look at 2 times what gives me 6v. 3v. So I know I'm going to have to multiply by 3v and what else? v minus 5 and v minus 4. So if I multiply the denominator by 3v times v minus 5 times v minus 4 to make an equivalent fraction, I'm going to have to also multiply the numerator by the same thing. Okay, so that's going to be a lot of work. Let me do my monomials first. 5 times 3v is 15v, right? And then I'm going to do this in steps. So for now, I will just do, that's v squared. Negative 4v minus 5v is negative 9v plus 20. And then when I come down here, I'll distribute that on my next line, okay? Everybody cool with that? Okay, the bottom one won't be so bad. 3v times what is 6v? 2. And that's the only thing I'm missing, right? So I'll just need to multiply the numerator by 2 to get 8. Yes.
For the top numerator?
Yeah. Did I make a mistake?
Well, I was just wondering, wouldn't you multiply v minus 5 and v minus 4 by 5?
I'm going to. So right now, I multiply my monomials together, 5 times 3v to get 15v. And then I multiplied the x minus 5 and the x minus 4. And then in my next step, I'll go ahead and multiply those together. Okay. I'm just kind of doing it in steps since there's so many things to do, so much multiplication going on. So now when I'm adding my numerators together, that top row, when I bring it down, I'm going to go ahead and distribute that. So that's going to be 15b cubed minus 135b squared plus 240v and then our denominator, we got to add that 8, not denominator, the numerator of the bottom fraction, all over 6v times v minus 5 times v minus 4. Now that numerator, we don't know how to factor cubic polynomials at this point, but does it have a greatest common factor that we could factor out and maybe we could reduce it with a 6? I don't think so. So that is the same answer that was given on the answer sheet, so we're good to go. Except for v cannot equal, oh, we didn't have to do exclusions on these, right? Okay, so that's your answer. Only other thing I would do in that numerator, if there was a greatest common factor, I would factor it out in case I could reduce it with a 6v, but it doesn't have one, so we're good. Okay, let's do number 16 was the next up on the requested list.
Miss Rayleigh, can you do 15?
I can. I'll do it after, well, I'll do that next. I'll do 15. So after I do these, then I'm going to move on to the complex fractions so that we have some time, and then the expanded. Y'all did really well on expand, so I don't know if y'all have any questions on that. So I'm going to do 15. I do. Yes, you'll have to come up here and get it. Oh, why did I write it like that? So go around to my desk, and those drawers, I think probably it's at the top drawer or the middle drawer, and there's just like a little packet of them. You can slide those, whatever that stuff is on top, you can slide it up so it doesn't. Probably right on top. I think it's probably in the second drawer, middle drawer. You're welcome. So I'm going to go ahead and factor this denominator. I know the variable's k, a is 1, so it's going to be easy to factor. Two numbers that multiply to get 12, I to get -7.
What was it?
Perfect. And there's a is 1, so we don't need to divide this line. Minus 4 divided by 5k, that's a monomial. We don't need to divide that, right? So in my least common denominator, what's the monomial going to be? For the least common denominator, what's the monomial going to be? 5k? I only have one of them, right? So 5k, that looks like a 3, it's 5. And then I'm going to need a k minus 4 and a k minus 3. Right on? Okay, so that top fraction, all I need, the only missing factor is the 5k. So I'm going to multiply the numerator by 5k. I'll distribute that, but I'll do it in my next step. And then that bottom fraction, I'm going to have to multiply by k minus 4 and k minus 3. And so think about that 4, think about it as a -4. So when you distribute the -4, okay? Coolio? So let's do the top. Let's distribute the 5k. 5k times 4k is 20k squared. And 5k times +6 is +30k. The denominator, I'm just going to do the first step. I'm going to put -4 times, and I'm going to go ahead and multiply those binomials. And then in my next step, I'll distribute the -4. So I have k squared, -3k, and then a -4k will make a -7k plus 12. So when I add my numerators together, I have 20k squared plus 30k. And then I have -4k squared plus 28k minus 48 all over the denominator, and I'm not going to multiply that denominator out because I might be able to cancel something. I might not. Looking at the answer sheet, no, the whole denominator is still there, so I'm guessing I'm not going to be able to cancel anything. So in my numerator, let me combine like terms and put it in standard form. 20k squared minus 4k squared is 16k squared. 30k plus 28k is 58k. And I only have one constant, so minus 48. Now, if we factor, that does have a GCF of 2, right? But if I factored that 2 out of the numerator, would it reduce with the 5 in the denominator? No. So that's why, in the answer key, that's why they didn't factor it out. But if you did, that's correct. You could factor out a 2, and that's the only factoring that can be done, I'm guessing. But because it wouldn't factor, it wouldn't reduce with the 5K, they didn't factor it out. But if you did on your paper, that's A-okay, it's right. But that's how, if it was multiple choice, that's how they were going to leave it.
For the number, okay, so like the second part, like your second
When I get the least common denominator,
fraction, when you distribute the -4,
yeah,
how, like, I understand, like, k squared is like k squared minus 7k plus 12.
Yeah.
That's what the two parentheses would equal.
yeah.
But what if you just, like, distributed, like, the -4 to k, like, all that, and, like, there's, like, longer than that?
You mean you did it at the beginning? So that's why I always say wait until you figure out the binomial first, because you over distributed. You probably distributed to both sets of parentheses and then it multiplied itself again. So that, and you don't want to do that. That's why I say, if you have that monomial, go ahead and distribute the binomials first. And then once you get that, then distribute the -4. Because basically you distributed -4 2 times. Because if you did it to both parentheses, then you distributed it twice unknowingly. And it gets confusing. So yeah, I would just wait and do it after. Okay. All right, number 16. All right, so before I get a common denominator, I'm going to factor my 2n squared plus 2n minus 12. I'm going to do it over here. 2n squared plus 2n minus 12. I already see I have a GCF of 2. So I'm going to factor that out. And so I have 2 times n squared plus n minus 6. Well, that's still a quadratic, so I might be able to factor that. If I could, I would need two numbers that multiply together to get -6 and add to get 1. -2 times +3 is -6, and -2 plus 3 is +1, so that works. And so I'm going to, my top fraction, I'm going to say 2 divided by, or 2 times n minus 2 times n plus 3. And then that other fraction, I'll just leave it the way it is. Okay, so we know we need a 2 in our least common denominator. We need an n minus 2, and we need an n plus 3. Coolio? So the top fraction, the denominator did not change, so the numerator won't change. Thank goodness. The bottom fraction, I'm going to need what? An n minus 2 and an n plus 3. So same thing on this one. I would multiply the n plus 2 and the n minus 3 first, and then distribute in the -6. Okay? So let's see. I'll do that in steps. So I have -6 times, I'm going to distribute the binomial, so it's n squared plus 3n minus 2n will give me plus n, and -2 times +3 is -6. So when I do my numerators, when I subtract them, then I'll go ahead and distribute the -6 on my next row. So I have 2 from the top fraction minus 6n squared minus 6n plus 36. Don't forget your denominators. So I'm going to combine like terms, write that in standard form, and see if I can factor anything out. So let's see, that would be negative 6n squared minus 6n plus 38 Now that has a GCF of 2, right? And my leading coefficient's negative, so I'm probably going to factor out a negative as well, even though in their answer they did not have the negative factored out, so I won't bother because I can already see what they have it as the answer. But I will factor out a 2 because that will cancel with the 2 in the denominator. You know what I mean? So if I factor out a 2, I'm left with negative 3n squared minus 3n plus 19 So then the 2's cancel. So if your answer, if you factored out the negative from the numerator, now it doesn't go away, it's still going to be up there, but you're going to need parentheses. But they didn't, so I'm not going to. So my answer, and I'm out of room, so it's just this. Negative 3n squared minus 3n plus 19, quantity divided by n minus 2 times n plus 3. Okay, I'm going to do 18 as fast as I can so we can do some complex fraction questions. And then if we have time after that, then I can go back and answer, do any other ones. But I want to make sure I get some from each section. Okay, let's see if we can factor 3k squared minus 3k minus 36. I do know there's a GCF of 3. So if I factor that out, I have k squared minus k minus what, 12? Is that right? So, over 36. It's a quadratic. So if I can factor that, I would need two numbers that multiply together to give me negative 12 and add to get negative 1. I'm thinking a negative 4 and a positive 3, multiply to get negative 12, add to get negative 1. So anytime you can factor, you want to factor before determining the least common denominator. Okay, so just the monomial part of your LCD is going to be what? My monomials are 3k and 3. Just 3k. And then I'm going to need a k minus 4 and a k plus 3, right? So that top fraction, I will have to multiply the numerator and denominator by k minus 4 times k plus 3. And then the bottom fraction, what will I have to multiply by? Just a k. Only thing I'm missing. Okay, so this top fraction, again, I would distribute these binomials first. Don't throw the 2k in right away. Distribute your binomials and then distribute the 2k at the end. So my binomials, that would give me k squared. 3k minus 4k would be negative 1k or negative k minus 12. Denominator, I'm adding 5k squared. Wow, they are pumped up. So let's see, that gives me 2k cubed. I'm talking about cheerleaders. For those of you at home, they're being loud up there. And minus 2k squared minus 24k. And then I have that plus 5k squared in that bottom fraction. Denominator, don't multiply that together. We want to see if something will cancel. So the numerator, I do have some like terms. So I have 2k cubed plus 3k squared when I combine like terms minus 24k. Do I have a greatest common factor in my numerator? K, right? And as far as numbers go, no numbers, just a k. Well, if I factor out a k, That'll be a monomial. I can reduce it with that 3k in the denominator. So I need to do that. And I'm guessing that quadratic can't be factored because they don't have it factored in the answer key. If it could, I would. But I can reduce k in the numerator and k in the denominator because those are monomials. And so my answer should be 2k squared plus 3k minus 24. Quantity divided by, don't forget your 3. 3 times k minus 4 times k plus 3. Again, you can distribute out that denominator if you would like. But the answer key, it's not distributed, so that's the way it will be on your test. And so that's your answer. So on the back side, complex fractions. So that would be 21 through 30. And it's 11:07 already. So no questions on complex fractions? 21 through 30? Really? I sure can. 21. Okay. How did y'all do on expanding completely? Pretty good on those? Okay. So let's see, 21. Try to write very neatly so I don't mess myself up with my own handwriting. Sometimes we are our own worst enemies. Y'all probably doing better on complex fractions now, probably because you're understanding least common denominators better. I'm guessing.
I think the thing that I've like personally still be bad on are things like fractions and adding fractions.
Yeah.
Everything else is pretty easy.
And it's probably because of the least common denominator. It's probably what gets you. Okay, so we have 4 fractions. The denominators of 3 of them are u plus 4, so we know we're going to need a u plus 4. And what else is our least common denominator? 2. So I'm going to multiply every single fraction by 2 times u plus 4. And remember, when you do that, that 2 times u plus 4 is in the numerator. So if you get confused, make it a fraction, put it over a 1. When I taught because y'all struggled on it so much, when I taught my second period, I started doing it like that, and I felt like they kind of understood it a little more, had less questions when I made it like another fraction. Because you know, when you're multiplying, if you have an exact factor in the numerator with the exact factor in the denominator, that'll cancel out, right? And so I just think about each of these now as just one, each of those fractions, think about it as a big giant fraction bar for each one, okay? Before you multiply it all together, reduce where you can. So top left, what can I reduce? The u plus 4, right? So now look, that technically turns into a 1. Now I only have 1s in the denominator of the top left. That's what you want to happen. Top right, what cancels? U plus 4 again. So the denominator, now all you have are 1s. Great. Bottom left, what cancels? U plus 4. So now all you have is the 1s in the denominator. Bottom right, what cancels? Just the 2s. Okay? So your whole goal is to get all of the denominators in each of the individual fractions to turn into a 1. You don't want fractions. You're trying to get rid of the fractions within the fractions. So now each individual fraction, whatever's left in your numerators, multiply that together. Okay? So top, and it's easy to like accidentally leave off something. Okay? So you got to be real careful in what you canceled out and what's left. So top left, I only have in my numerator a 2 times 4, right? So I have 8. I'm adding the next fraction. The denominator is all 1, so I'm good there. I have u plus 5 times 2. Let me go ahead and distribute this. So that would be plus 2u plus 10. Y'all good with that? All over Bottom left, I have 2 times 2u plus 10. So that's going to be 4u plus 20. And I'm subtracting, oh, sorry. I'm subtracting u plus 5 times u plus 4. So let me, I'll start to multiply that together, and I'll need to put parentheses or brackets because I'm going to have to distribute that negative. I'm not just subtracting the first term, okay? Be careful about that. So when I distribute, I get u squared plus 4u plus 5u would be plus 9u plus 20. My numerator, I'm going to combine like terms and get 2u plus 18. The denominator, I'm going to distribute that negative and then combine like terms. So I have 4u plus 20 minus u squared minus 9u minus 20. In my numerator, I'm going to factor out the 2 just, and maybe I can reduce it. I don't know. I see in the answer that the 2 is not factored out, so I'm sure you can't, but just because I can, because it's a GCF, and then if not, we can put it back together. Denominator. Oh my gosh, they left negatives in the denominator. I would never do that, but they did. I have negative u squared. 4u and negative 9u make negative 5u. And 20 minus 20 is 0. So me personally, I would have factored out the negative and moved it to the numerator. I see in the answers they did not. To me, that's a big no-no, but hey, I didn't design the test key. So they did not, and then they also distributed in the numerator. So that's one of the things that when you have a multiple choice test, you know, when I've been giving you the notes, a lot of times there's multiple different ways for you to write your answers. You know what I'm saying? So you have to be able to look at the answer key, and if your exact answer is not there, look at the answer options and see if there's one that means the same thing as yours. It's just in a different form. Coolio? Okay, are there any questions on expanding before I take more questions on complex? Any questions on expanding? I feel like y'all did very well on the homework for that assignment. I'm not giving you Pascal's triangle, so you've got to be able to write that on your own. Pretty easy. Y'all know how to do it. If not, make sure you figure it out for the test. Ask me. If you weren't here when I taught expanding or the binomial theorem, make sure you watch the video. Okay, so no questions on expanding. All right, let's go back to complex fractions. Do you want to see any of the others done? We have 5 minutes. 25. Look at that answer. Goodness. Oh, you said 27? Okay, and look at number 25. The way they gave the answer, the numerator is not in standard form. I would never want you to leave it like that, but that's how they left it. So that's what you would see on the answer choice. Why? I don't know. Okay, you want to see 27? Okay. Okay, so my monomials, we have a 5, and an x squared. So when we determine the LCD, the monomial part, what's going to be the LCD just on the monomials? 5x squared. And then won't we need an x minus 1 as well? So I'm going to multiply, so let's like think of that as one giant fraction. So I'm going to multiply each fraction by the least common denominator. Okay, so top left, the x minus 1 cancels. Top right, the x squared cancels. Bottom left, only the 5 cancels. And bottom right, only the 5 cancels. I probably should have started this on a new sheet of paper. I have a feeling. So each individual fraction, whatever's left, multiply it together. Okay, so top left, 5x squared times x would be 5x cubed. And then I'm adding the next fraction, so plus. Top right, I have a 4 times 5 times x minus 1. So won't that be 20 times x minus 1? So to save room, I'm just going to go ahead and distribute that. So that's 20x minus 20. All over. Bottom left, x squared times x minus 1 times 4. Isn't that the same thing as 4x squared times x minus 1? So I'm going to do that before I bring it over. So that would be 4x cubed minus 4x squared. And then I'm subtracting the next fraction. And I'm going to have multiple terms there. So I'm going to make sure to put a bracket or parentheses because I'm going to have to distribute that negative. It's not just one term. So that's going to be 16 times x squared times x minus 1. So that's 16x squared times x minus 1 would give me 16x cubed minus 16x squared. And I can see that there is a GCF in the numerator of 5, right? But they did not factor it out. Why is it x cubed? Oh. Top left, 5x squared times x, which should be 5x cubed. 5x cubed. And then plus, oh, is that us? Ah! All right, so it's lunchtime, y'all. At home, I'll finish working this problem, and then when they come back, they'll be able to see it. So I'm going to distribute that negative in the denominator. Like I was going to say, there is a GCF of 5, but they didn't factor it out, so I'm assuming it can't be, it won't reduce in the end. So in the denominator, I am going to distribute that negative. So negative 16x cubed plus 16x squared. And I'm going to write that denominator in standard form, combining like terms.
I understand. It's just like there's so many things that you have to do, and if you don't do it, it throws your whole problem off.
Right.
Like, if you don't get your least common denominator right.
Yeah. Then, I mean, that's why I am giving you multiple choice. Okay. So the reason that the answer key, the numerators are all, is that leading term's negative, because this time they factored out the negative from the denominator. I'm just going to start on another sheet of paper. So they factored out that negative in the denominator. I don't know why sometimes they do and sometimes they don't. It does not make sense to me. So that would make it 12x cubed minus 12x squared. And like I have always told you, don't leave a negative in the denominator. So they moved it to the numerator. It's not just the first term. So parentheses are important. You're not just subtracting the first term. But they did not leave the negative outside parentheses. They went ahead and distributed it. And that is how they got that answer. All right. So let me see if I'll see what y'all said. $27 and $28. So I did 27. Yasmin, are you dying to see 28? Because I'm hungry, but if you were dying to see it, I will do 28. Are you sure? Yeah, I can do it. I'm hungry, but I will do it for you if you really want to see it. Well, if you could you do 30? Okay, I'm going to do it quick. Like I said, I'm hungry. 30 does not look quick, but Okay, on 30, the least common denominator is going to be 16 times u plus 2 times u plus 5, or u minus 5, sorry. So we got a lot going on there. 16 times u plus 2 times u plus 5. So I'm going to multiply every term. Oh, u minus 5 to u minus 5. Should have given myself a little more room up here. U plus 2, u minus 5. So top left, the 16s will cancel. Top right, u plus 2 will cancel. Bottom left, u plus 2 will cancel. Bottom right, u minus 5 will cancel. So in each individual fraction, I'm going to multiply what I have left. Oh my gosh, look at the top left. That is crazy. Okay, so on the top left, I have literally 3 binomials. U plus 2 times u minus 5 times u plus 1. I need to pick 2. I need to pick 2 to start with. So let me just rewrite everything down here. And then I'm going to put that 16 first, and then u plus 1, u minus 5. All over, Kayla, you did not pick the shortest problem. All over 16
My
times,
bad.
huh?
I said my bad. It's just that was so confusing.
I can see why. I'll try not to give y'all one that's crazy on the test. Plus 16 times u plus 2. If y'all see me make a mistake, tell me, because there's a lot going on here. Do not cancel anything out at this point, okay? If the whole numerator was only factors and the denominator was only factors, then you could cancel stuff out. But when you're like adding numbers and subtracting numbers, that's not all factored. If those 16s weren't there and it was all being multiplied together, cool, we could cancel stuff out. But it's not, so we cannot do that, okay? So top left, I'm going to multiply u plus 2 and u minus 5 together first, and then I'll distribute into u plus 1. So that's u squared minus 5u plus 2u minus 10. And all of that will have to be multiplied by u plus 1. Minus 16. Again, don't distribute that negative 16 yet. Let's multiply u squared minus 5u plus u minus 5. I'm doing this quick, so I hope I don't make mistakes. Bottom, goodness, 16 times u squared plus u minus 5u minus 5 plus 16 times u squared plus 2u plus 2u plus 4. I can't believe I give y'all such a thing. So let me take care. I'm going to combine like terms first. And then I'll come back and distribute that u plus 1. Same with this next one. That's u squared minus 4u minus 5 all over. It did not seem this difficult when I assigned it. Okay, now keep on going. My numerator, I'm going to distribute that top left. So let's see. I'm going to do that on the side. I need a whole new piece of paper. I need a little box. So messy. I'm trying to hurry so I can eat. U cubed minus 3u squared minus 10u plus u squared minus 3u minus 10. That's going to give me, for the top left, I will have u cubed minus 2u squared minus 13u minus 10. And then the right side won't be so bad. All I got to do is distribute the negative 16. So minus 16u squared. What's 16 times 4? Plus 64u. Plus 80. All over Let me distribute those 16. So 16u squared minus 64u minus 80 plus 16u squared plus 64u plus 64, I think. Yeah, okay. Numerator, let's combine like terms. So I have u cubed. That's done. Negative 2u squared and negative 16u squared would be negative 18u squared. Negative 13u and positive 64u would be positive 51u. And a negative 10 and a positive 80 leave you positive 70. Ooh, so far I have the same thing as the answer key. I'm so excited. All over 16u squared plus 16u squared is 32u squared. Negative 64u and positive 64u cancel. And negative 80 plus 64 gives me minus 16. This is the way they have the answer, so I'm not going any further. I could factor out a GCF of the denominator, but it won't cancel with the numerator, so that's probably why they did not do that. Cool? Can we all go eat now?
Yes, ma'am. Thank you.
You're welcome. All right,
Yes, ma'am.
so y'all, I will see you on Monday and we'll have the test. If you have questions on any of the other ones, if you'll just email me, send me an email and I'll work it out and send it back to you if you have any other questions. Okay. Over the weekend, I have a busy weekend, so I'm probably not going to see it. So make sure you email it to me today so I can get that taken care of. All right. All right. I'm signing off. See y'all next class.
Bye, Miss.
Bye. Have a good weekend. And oh, next Wednesday is Veterans Day. We don't have school next Wednesday. Okay.